Hello and welcome to part 2 of the first steps in steel construction. Basically, in the previous video, we laid the profiles, laid the purlins, and installed the cross braces. Now we want to take the next steps so that further construction steps can be seen. Basically, I am still missing a cross brace on this side, so I would like to install it here as well. For this, I select the profiles again, and as in the first video, I can set the values, but I confirm this and can, of course, change it at any time later through the feature. That means if the fastening here is too much for me, too many screws, then I can easily change this here using the feature. So in the next step, I would like to create the connection of the purlin here. In addition, it is like this. I have all the views here every time. Of course, I also have the option to work only with the active view and can switch back and forth here. I personally prefer this method of working to some extent because it allows me to address certain points more specifically. Here, I could create a thick joint as an example, 2001, where HiCut also queries back and forth on which profiles. That means I select the profile, so the purlin, before I now have the purlin, I would like to have this here. So the beam, that would be the beam, and select the thick one, and could set my values here, whether I want stiffeners on the beam or on the purlin. Basically, why did I rearrange this? So that I can really find my way around here with the further attachments. Of course, I can also define my screwing here, which screws I want to have, which connection I want to have. I can set all of this here, and with OK, this joint is installed, as an example, with this connection. I could of course continue with the further steps here, that is, I could naturally continue this and again click on Beam, Purlin, 2001, go to Preview or OK, and could thus install them one after the other. I would like to connect the purlin in the middle here. For this I will again use the profiles and the beam. I can set my values, adjust my screws, adjust my stiffeners, and using OK, SOS, EOS, install this joint again. So basically, this would then continue like this. I would like to address the next option here, which means I can of course extend the profiles at any time, meaning I want to let these profiles overhang on the left side as an example. For this, I can use the right mouse button to trim to edge or extend as an example. That means I could say here, for example, 250, and want these profiles to extend 250 on this side or the same on the other side. Now I am checking my structure in this case. This belongs to my roof. That means I drag and drop this into my roof to have a clean structure as well. Here you can find loose parts where my screws are included. Here you can find the assemblies of the individual beams. So, in the next step, I want to install my trapezoidal profile on the roof. There are two options for this. On one hand, I could use profile installation to do this automatically. However, since this module is often not available, at the beginning, when trying it out, I would like to draw it by hand and then copy it further. That means I basically create a plane here, which I place on the top edge of the IP, die key, and essentially select my trapezoidal profile from my profile library. there are trapezoidal profiles here, or alternatively, you have the option in the catalog to select various profiles and manufacturers from different manufacturers. However, I stay here in my standards library and select my trapezoidal profile, the material quality, and can easily and efficiently install it precisely using 10, specifying the start and end points. You can clearly see in the preview that I have obviously chosen the wrong insertion point here. Of course, I can change this and I can confirm it with the middle mouse button, immediately installing this profile. Of course, I can definitely extend this profile at the front and back by a certain value at any time. And I will also create a structural assembly for my trapezoidal profiles here and definitely ensure its stability. So I simply copy this trapezoidal profile, which means just right-click and repeat part. I enter the number. In this case, I try with 6 and then copy it again if necessary. Here, I simply have the first point and specify the insertion point for the second one right away. And so I copied this a few times, saw that it was not enough, and copied it again. In the first video, I worked with the parametric copy function. I also want to show here that there are, of course, other options. You can see here in 2001 that this profile is too much. And this profile actually needs to be trimmed. To do this, I select the profile with the right mouse button, choose to extract in this case, and select the surface, which means a vertical surface. I haven't extended this here, of course, but I want to leave it here on this side. I could take this edge as an example here. That would be my connection edge 2001. And I want to cut out and trim the right side. The tool immediately cut everything straight here, and thus I have the roofing in place right away. Furthermore, I would like to use other functions here in HiCut, which are very helpful, specifically the cutting operations. To do this, I will display all views again and create a sectional view here. I generate this with the right mouse button, want to create a sectional view, select the section line for this, which means I want to draw a vertical edge here. And of course, I have the options with the various settings for the section depth. To influence the designation, I want to have the underlying parts here, and in this case I say generate, and HiCAD immediately generates a new sectional view for me. In this sectional view I can continue working immediately, which means I can easily create a new sketch here. And as an example, I can right-click to place it into the layer, into the screen layer. For this, I now have the possibility to draw directly in the section, which means I want to represent a section course. Here. Of course, I have the option here, as you can see from the angles, to also change this grid. In order to draw the correct dimension, right away. Of course, I can also subsequently modify these distances and dimensions with intelligent dimensioning to define the angles and lengths I need much faster. Next, I right-click on the sketch, instruct it to generate a new sheet metal, and select my sheet thickness or material quality from my semi-finished product parameters. I can also define a certain length here. If I already know in advance how long I want it to be, I can immediately enter it here, and with OK, this bent sheet metal will be generated in the section. I can also see this immediately in the Architect 3D model, meaning that no matter where I have created it, it is shown to me immediately at every point. You can see here that I placed this in the wrong position in the section, which means I actually chose the wrong edge. Here, I can correct this here either in the D or in the D right away, right? That means I select the edge and copy it downwards. HiCAD moves it in the D, and I also have it immediately in the D at the correct position. I could place this sheet metal at the corner here. With the right mouse button, I can say, for example, I want to move this point, press the Enter key to access the advanced point options, and here I can choose, for example, Load to Surface. Select the surface of the beam, and HiCAD immediately moves this sheet metal to the outer edge of this sheet metal. Of course, I have additional functions here, such as how I can copy this again. That means I select the main sheet metal part. Say, in this case, copy. Specify the number as 1000 and simply copy it twice further. Then, in the last sheet metal here, I can define the length. However, I would like to immediately create a structure here where I define my gutter, move these 3 aluminum sheets into the gutter, and view this in the front view. Now I see that I have divided this gutter into 3-meter pieces. And in this case, on the right side, this gutter is protruding. But I want to have this gutter centered and edge this gutter on the side. To do this, I move this gutter to the center. That means I select this edge here and say up to the outer edge. And in this case, say divide by 2, and thus the gutter is now exactly in the middle of the cardboard, and I can continue to edit this normally here. That means I switch back to the 3D model, tell it to display only the active part, and I want to continue editing this gutter. First, I start by modifying the length. I want to extend this edge to this point. Middle mouse button. It is then executed on this sheet metal up to this point, and thus I have first defined my lengths here. Furthermore, I would like to bend a side flange here, meaning I would like to bend a flange here. I can define a fixed length and my dependencies here at the same time. I will do this here, using the same function as before with the extending, as I don't know it by heart now, but rather want to determine the length geometrically. For this, I start the function again up to a certain edge and want to pull up to the quadrant point here and do the same here. And next, I will start with my corner processing. Since I have pulled this sheet metal upwards, I now have many options to further process it. One possibility would be to extend this surface, meaning the entire surface, with a certain cutting clearance. In this case, I say 4 to this surface. Thus, I have shortened this entire cross section here. I do the same here as well. Here, on this surface, and the corner was processed for me. In the next step, I want this corner to be ground. For this, I select Miter corner, choose my first edge and my second edge. And now I have the option in the corner mode to set a proportional overhang with a factor of 1. This extends the first edge, resulting in the grinding of this side. Of course, I will do the same here on the second page as well. Here, of course, the first edge here, and here, and middle mouse button. And thus, I have naturally also created this groove here. Next, I want to create the drain here. For this, I can create a processing plane here and select the corresponding pipe from my profile library, which contains various types of pipes and profiles for different applications. I will choose the appropriate dimension for the pipe, ensuring it fits the requirements of the project. Next, I will select the center point, which is crucial for accurate installation. I will set the installation direction perpendicular to the processing plane, ensuring stability and proper alignment. In this case, the pipe should be 100 meters, which is the standard dimension for this type of installation. And now I can also define this pipe at the correct position. That means I can press R on the keyboard, hit enter, and specify the center point here. Now I can set a value in the X direction, say I want 100 millimeter here, and 0 in the Y direction, and thus the pipe is in the correct position, and with the middle mouse button this pipe is also installed. Next, I simply need to move this pipe down by the edge length because I drew it at the top, and thus I have also defined my pipe here. I also want to define the recess, that is, the drilling for the drain, and thus I have immediately defined my drain here as well. Of course, this carport is by no means structurally finished yet. This is intended to be a first insight, and in the next video we will cover the various evaluations, such as how to generate evaluations, namely drawings, parts lists, and release plans for this cardboard.